Hi, this is Raphael Mudge, the creator of Cobalt Strike. When you're replicating an advanced threat, you do not want your traffic to go to and come from one IP address. Quite frankly, that's amateur stuff. In this video, I will show you how to set up cloud-based redirectors and use them with Cobalt Strike to replicate an adversary who has actual command and control infrastructure. Here I am in Kali Linux. I'm going to connect Cobalt Strike to a Cobalt Strike team server in Amazon's Elastic Computing Cloud. Let me put in my nickname, and I'm now connected to my Cobalt Strike team server. This server is in the internet. It has a public IP address. I've also set up 6 servers to act as redirectors. A redirector is nothing more than a hot point for traffic coming from the target's network to go through before it reaches you, the attacker. I've set up 5 nodes to forward traffic from port 80 to my team server on port 80. For this demonstration, I'm using SOCAT to do the port forward. You can use IP tables if you like. I like SOCAT just because it's very quick and easy to set up. So here we have TCP listen 80, and I'm telling SOCAT to fork each connection and manage it in its own process. This makes it so SOCAT will fork a new process, manage any connections that come in, and wait for a connection to come in instead of just running, waiting for a connection, and dying. And I've set up 5 nodes to act as redirectors on port 80 with SOCAT. Now let's go ahead and set up node number 6 together. I'm going to SSH into the system, become root, and I'm going to install SOCAT. Just do an apt-get install SOCAT. Now, I intend for this 6th system to be a one-time use redirector from Interpreter. So let's go ahead and set up a listener, port 443, and let's have it forward any connections that come in on 443 to our team server on port 443. And there we go. Our 6th redirector is now set up. Now, let's go back to Cobalt Strike. You may be asking, how do we take advantage of these redirectors? Well, let me show you. Go to Cobalt Strike, Listeners, and let's press Add. I'm going to create a listener first for HTTPS Interpreter. Let me go ahead and choose the payload, Windows Interpreter, reverse HTTPS, and we'll put in the port 443. On a listener by listener basis, I also have control over the host that the listener should call back to. So right now, the default host happens to be the IP address of my team server. But I can put in the IP address of the redirector that you and I just set up and use that instead. Let's go ahead and press save. Now, whenever I try to spawn this HTTPS interpreter session, it won't come to me, the attacker, directly. Instead, it will bounce through our cloud-based redirector. Now, let's go ahead and set up a beacon listener. Let's press add and create a listener. Call it HTTP beacon. And let's go ahead and scroll to the proper payload name, Windows beacon HTTP, reverse HTTP. And let's go ahead and port in the port. Just like with our interpreter listener, I happen to have control over which host beacon should connect to and stage itself from. Let's go ahead and put in one of my redirector IP addresses. I'm going to use the 5th one, which happens to be 54.221.79.143. Now, when I press save, Beacon is going to ask me which host it should beacon back to. Let's go ahead and put that information in as well. Here I can provide a comma-separated list of IP addresses, host names, or a mix. I'm just going to use my 5 different IP addresses. So here are my different redirector hosts separate from the actual interpreter session. Now, what will happen when I use a beacon in an attack, the compromised system will connect to this first host, download beacon, inject it into memory, and then beacon will rotate through these different beacon addresses, okay? In that way, I look like an attacker who actually has control of real infrastructure. Now, let's go ahead and set up an attack. Let's go to attacks, web drive-by, signed applet attack, and let's tell the signed applet to serve our beacon listener. We also need a Java listener, so let's go ahead and create one real quick. We'll just call it Java Materp. And I don't intend that will trigger this at all, so I'm not going to bother too much with useful parameters. And let's go ahead and press launch. And there we go. We now have our signed applet attack available at this URL. If I wanted to, I could set up a Cobalt Strike on a team server on another EC2 instance and set up the applet attack there to serve one of these listeners. Or I could press the Set lhost button and change what my team server thinks its default IP address is and serve this attack through a redirector. It doesn't matter. Let's go ahead and press OK. And let's go to our target. Here I am in Windows 7. I want you to see that this is a system with antivirus. It's an up-to-date Windows system. It's got Internet Explorer 11. All kinds of good stuff, typical of what you might see out in the wild. And over here, I want you to see that I have Security Onion running with EtherApe. EtherApe is a network visualization tool, and it's running inside of my target's network, okay? Any traffic inside of my target's network will show up here, and any connections to the internet will show up here as well. My target is 172.168.80. Now, watch what happens when I go grab this applet. You see a purple connection to my system in the cloud, okay? That's the target downloading the Java applet. Now, if I, the target, accept the risk and run this applet, what you're going to see is the target will download Beacon and inject it into memory, and then it will go dark until Beacon phones home again. So let's go ahead and press run. And you can see there's Beacon getting downloaded from 54.221.79.143. That's one of my redirector hosts, right? And now, of course, it goes dark again because the compromised system is not communicating with me. Here we are back in Kali Linux. We can see there's our target system, and there's what Beacon thinks is the firewall because that's the redirector it came through. To see our beacons, go to View, Beacons, and by default, Beacon is coming home on a 60-second interval. Let's go ahead and change that so you can see the actual redirectors in use. I'm going to go ahead and right-click, Sleep, and I'm going to change the sleep time to 6 seconds. And press OK. Now, you're going to see the target system phone home to one of our redirector hosts, 2322.72.55. And there it is, going to another redirector host. And in a moment, it's going to go to another one. Every 60 seconds, the target system is going to phone home to a different host, checking if there are tasks. This is much like what real malware would do out in the wild. penetration testing tools? Not so much. So Beacon is phoning home on a 6-second interval. Imagine if I made Beacon phone home on an hour interval. Now, every hour, a network defense team has the opportunity to observe one connection. That is going to be a lot harder to catch and block. Now, let's go ahead and spawn a interpreter session. Let's go ahead and go right-click. Oops, there we are. Right-click, spawn, and let's choose our interpreter listener. When I task Beacon to download this or to run this interpreter listener, it will connect to a redirector host, download interpreter, and interpreter will start connecting back to this over port 443. So let's go ahead and choose. In about 3 seconds, you'll see the check-in to our redirector. And then you're going to see HTTPS interpreter get downloaded from our redirector host. And now we have lightning bolts. We've got a HTTPS interpreter session. You'll notice that this green line for HTTPS is solid because interpreter is phoning home all of the time. That's one of the big differences between Cobalt Strike's Beacon and interpreter. Interpreter phones home a lot. Beacon can go really low and slow. But the point here is I want you to see that the target is not talking to us, the attacker, directly. They're talking to our redirectors. And this is really nice because I'm controlling one team server, but it looks like I have multiple IP addresses. And I can do everything you'd expect. I can open up a command shell. I can take a screenshot. And all of this is going to happen through my interpreter session, for example, right? And this is going through my redirector infrastructure. Now, let's say this IP address was blocked. Okay, no big deal. Spin up another node, set up SOCAT or some IP tables rules, reconfigure your listener, and task Beacon to give you a new session. You're right back where you left off. This is a way to make whack-a-mole really frustrating for a network defense team. So that's an example of using interpreter through a redirector with Cobalt Strike. Now, let's say I want to use interpreter, but I want interpreter to phone home to multiple systems. Well, in the Metasploit framework by itself, interpreter can't do that. But with Cobalt Strike, it can. Let me show you. Let's go ahead and kill this interpreter session. Okay, and now it's going to be gone. And let's go to our Beacon. And let's go ahead and right-click, go to Interact. And I'm going to make Beacon go into what I call interactive mode, meaning it's going to check in multiple times a second. What you're going to see now is purple lines, one for each of our redirectors, okay? So here, we have this compromised system phoning home to each of our systems. I can tunnel traffic through this. If I want to tunnel interpreter through Cobalt Strike's Beacon, all I have to do is type interpreter and press enter. Beacon will then inject interpreter into memory and set it up to tunnel its staging process and all of its traffic through Cobalt Strike's Beacon. And because I'm tunneling through Beacon, my interpreter traffic is actually going to go through all of these different redirectors. So now my one interpreter session isn't phoning home to one system, it's phoning home to 5 of them. And here I have my interpreter session. And you'll actually notice it's a little bit faster than HTTPS interpreter. And I can interact with the command shell. I can grab a screenshot. Do you see how different nodes light up depending on when I do an action? I can even tunnel traffic through it. So if I do interpreter interact desktop, I can pull up the user's desktop. and tunnel it through Meterpreter, which is being tunneled through Beacon, through our redirectors. And you can see how all of our redirectors are getting a little bit fatter because a lot of traffic's going through them. And there's the target's desktop. Now, one thing I'd like you to keep in mind is that I'm doing all of this over the internet, okay? This isn't just my home lab calling home to my home lab. This is all happening through Amazon's Elastic Computing Cloud to my test network here at home. So here I am controlling VNC, splitting the traffic through 5 different redirectors. And what's kind of cool, if I want to keep the Meterpreter session alive, but I'm not doing a lot with it, well, I could slow the communication down. I could tell Beacon, hey, phone home every 10 seconds, which will introduce artificial latency into my Meterpreter session, but 10 seconds is enough of an interval to keep my Meterpreter session alive. And now, every 10 seconds, Beacon is going to phone home to a different redirector host. If I go interactive again, give it a moment, checks in, I can resume using my Meterpreter session. Okay? My connection wasn't disrupted. So that's an example of using Cobalt Strike to work with listeners that use redirectors. Okay? Redirectors are a great way to have multiple points of presence on the internet, to make your sessions far more resilient, and to give each session its own IP address to frustrate a network defense team and work like a real advanced threat actor.